Good morning. Welcome to another example of method of sections. I have the free body diagram of our truss. It is supported on the left-hand side by two pin connections, one pin connection at K, one pin connection at A. Our problem statement are to find the forces and the members HG, HE, and DE. We're using the method of section, so let's go ahead and make a cut so we know where that is. We're going to look at this section here, and I'm going to look at the right-hand section. So I'm going to pause the video for a minute while I get the free body diagram of the right-hand section drawn up. See you in a minute. All right, thank you for your patience. I have the free body diagram of the section that I'm going to be working with on the left-hand side. Because we're not working with the section that includes the supports, there's no need for us to do the calculations for those reactions because they won't come into play. As you can see from my free body diagram, they're not on there anywhere. I think we're going to need a couple measurements before we get started, so let's figure that out. I think we're going to need this angle, angle F. Angle F and angle E are exactly the same. I mean, I know you're looking at my drawing and you're like, hey, that doesn't look like they're the same. Hey, pretend like every single one of these lines, the segments between K and J and I and H and G look, I mean, they are exactly the same. I mean, just pretend like that. A little bit difficult for me to draw to get it like that, but pretend like that, and maybe that'll help us out. So this angle we can find using the arctan function. Inverse tan of 4 over 3. 4 is the height of GE, 3 is the length of EF. The arctan of 4 over 3 is equal to 53.13 degrees. That's going to be the same measurement as E. You can see it over here on the big picture. If we were looking at angle E, HD divided by DE, 4 over 3. And that means that this is going to be 90, angle G, 90 minus 53.13. Which last night when I was practicing was 36.87 degrees. So we'll pretend like that's true for today also. All right, I'm ready to start. What do we have? So we've got, so in the Y direction, it looks like we have 3 Y components. So the external force at E, the external force at F, and then the internal Y component of HE. So let me go over here and see if we can kind of get us a little thing going on like I've been trying to do in the previous videos. And certainly in my homework, I try to do this. So kind of that's what I've got going on. This is HE. This is 53.13 degrees. That means this is HE cosine 53.13. And this is HE sine of 53.13. And we ought to be able to pick some of this stuff up pretty quick now. Summation of the forces in the Y direction would be negative 1,500 pounds minus 1,500 pounds plus HE sine 53.13 degrees is equal to 0. Add 3,000 pounds to both sides and divide both sides by sine 5313. We get 3,000 pounds divided by sine 5313, which gives us a value of HE of 3,750 pounds. It is positive, which indicates that I have HE in the right direction. HE is pulling away from the pin, which would be a reaction to compression, or I'm sorry, it would be a reaction to the member being in tension. So HE is 3,750 pounds tension. I think I can take, if we were to look at the summation of the forces in the x direction, we'd have D and GH. That'd be too many unknowns. So we're gonna have to pick them up, at least one of them, by themselves. So let's take a look at taking a moment about point E. If we take a moment about point E, it's much easier to do it about point E, because that means that the external force at E is not a player. It means D is not a player. It means HE is not a player. It does let us show that GH is a player. And we know that GH is 4 meters away. And the external force at point F is a player. And the external force of point F is 1,500 pounds, and it is 3 feet away. So if the rotation is about point E, GH causes a counterclockwise rotation, which is positive. And the 1,500 external force at F causes a clockwise, which is negative. So we like that. Okay. GH times 4 feet plus negative 4,500 pound feet equal to 0. That means the GH is equal to 4,500 foot-pounds divided by 4 feet, which gives us a value of 1125 pounds. That number came out positive, which would be an indication that I have GH in the correct direction. The reaction at GH is pulling away from the pin, which would indicate that the member is in tension. So I'll update our problem statement. 1125 pounds in tension. That leaves us, so we've got this one here is the 1125. Let me get a different color so we know that we added that. 1125 pounds here. This one was 3750. It looks like we can now grab the last of the verticals, the D. So let's see if that works out. Summation of forces in the X direction. Negative 1125 pounds minus 3750 cosine 53.13. That's the X component of HE. We already sense that I have D in the wrong direction, but we'll write it the way that I have it. So this is the negative 1125 pounds minus 2250 pounds. I'm going to add D to both sides. Negative 3375 pounds is equal to DE. The negative is an indication that I have the force shown in the wrong direction. Go up here in our red marker, which has been what I've been using to indicate that. And 3375 pounds compression. reaction is going into the pin, which would be an indication that the member is in compression. So that's another easy one. We like these. Hey, have a great day. I'll talk to you guys later.